We are Pro-RAM, Constructive Mentality, shaping the industrial future. Visit our website for further information and request quotation. Hello, thank you for being with us and watching this video. It is part of our series about PolyWorks software. You will learn many practical tips on how to use the software to achieve your goals or simply improve your work. We encourage you to like the video and subscribe to our channel to do not miss further useful information. We also invite you to leave your comment about this material. We are open to any suggestions. The content and services we create for you. In coordinate metrology, you'll often see references to I, J, and K. But what do these vectors actually represent, and why are they so important when working with planes and lines? Let's start with planes. Whenever you create a plane in PolyWorks from a CAD model, the software automatically assigns an orientation vector. This vector is defined by its I, J, and K components, which describe the plane's normal direction in 3D space relative to the active XYZ coordinate system. For example, if a plane is perfectly horizontal, its normal vector might be 0, 0, 1, meaning it points along the z-axis. If the plane is tilted, the I, J, and K values change accordingly to reflect that orientation. In other words, the vector tells us how the plane is facing in space. Now let's look at lines. Here, I, J, and K represent the line's direction vector. They define the orientation of the line in the coordinate system in relation to its X, Y, and Z components. For example, a line running parallel to the x-axis will have a direction vector of 1, 0, 0. If it's angled, the values adjust to describe that precise slope in 3D space. So, while the idea is the same, I, J, and K always describe orientation. For planes, they define the normal or perpendicular direction. For lines, they define the actual direction in which the line extends. Understanding these vectors is important when setting up alignments, creating datums, or simply interpreting feature properties. Mathematically, I, J, and K are the components of the unit direction vector. They are the direction cosines, meaning the cosines of the angles between that vector and the X, Y, and Z axes. Keep this in mind the next time you're analyzing geometry in PolyWorks. Those small IJK values carry a lot of meaning. Just short examples to show you what's the case, because in real measurement results, nothing is perfect. Planarity, nor perpendicularity, nor angles. While creating features, you have to pay attention to the I, J, K. Sometimes it seems that planes are facing X, Y, Z coordinates, but sometimes they don't. It may waste your measurements. The workflow of measurements may affect the measurement results. For example, when measuring a cylinder, you have to pay attention if the measured axis has the same direction as the nominal one. You can simply verify it checking the measured and nominal cylinders' I, J, K components. We encourage you to schedule a PolyWorks training with us. We will explain this and all the other topics for you. Thank you for watching. We encourage you to visit our website and read more about us.